The views and opinions expressed on this show belong solely to the hosts and their guests and do not reflect the views of any on-site institutions unless explicitly stated.
What's up, everybody? My name is Steve Vanderwall.
And I'm Justin Klosser.
And we're your hosts of Cannabis Cum Laude, a podcast devoted entirely to cannabis. We're going to talk cultivation, business, medicine, science, politics, advocacy, culture, and everything in between. Because let's face it, the cannabis industry is complicated, it's robust, and it has a ton of moving parts. So it's going to be our job to help you understand it a little bit better. So tune in every Friday morning for a brand new episode. And if you have a question that you'd like to have us answered on one of our shows, email us at questions@cannabiscumlaude.com.
What's going on, everybody? Welcome back to another episode of Cannabis Cum Laude. And this week's episode is really awesome because on March 8th, 2021, the world-renowned multidisciplinary scientific journal Nature published an eye-opening study from a team of researchers out of Colorado State University about the profound greenhouse gas emissions that come from indoor cannabis cultivation. On today's episode of CCL, we have the distinct pleasure of interviewing the lead researcher of the publication, Hailey Summers. Hailey Summers grew up in Alaska, where she developed a passion for the outdoors and sustainability. She is currently in Colorado finishing up her PhD in mechanical engineering with a focus on sustainable development. With these skills she's developing, her goal is to help improve the world that we live in. Hailey, thanks so much for coming on. Welcome to the show.
Thanks, guys. Thanks so much for having me. I'm really excited to be here.
Yeah, a huge congratulations to you, first and foremost. What a major accomplishment. This has been making waves throughout the industry for the last week. And it's really cool to see, this is kind of the first class of academics that have really been able to study the plant in depth. And I think it's papers like this that are really going to shape the industry moving forward. So props to you.
Yeah, thanks a lot. I'm glad to hear it.
Yeah. So can you kind of give us a high-level overview of this paper?
Yeah, so from the surface, we developed a model to quantify the greenhouse gas emissions from general practice of growing cannabis indoors. And then from there, once that model was built, we ran it across the U.S. to understand if there were different geographic impacts.
Nice. So that model, how exactly do you go about building that?
The model essentially, it started as just one basic warehouse, right? Like, I'm a mechanical engineer. I looked at it as a heat transfer problem, and I said, I've got plants. They need basic energy and nutrients to grow, and I turned it into a giant heat transfer equation. And then I also expanded from there to include some environmental accounting methods called life cycle assessment. And what's unique about life cycle assessment is it essentially also accounts not just for the energy, like from emissions that would come from energy like electricity or natural gas, but it also accounts for material inputs. So an example is looking at fertilizer requirements, right? These plants need some fertilizer, and that fertilizer is produced somewhere upstream. And so with life cycle assessment, what we did was we said, we are going to attribute any emissions for producing those inputs like fertilizer. And we're going to burden that, assign that to the cannabis as it's grown through its life. So we holistically looked at what it takes to grow cannabis indoors. And from an energy perspective, I can also talk about that briefly with my heat transfer equations. So, it depends on where this theoretical warehouse is located, because plants need that fresh air to grow, and that fresh air from the outside is basically just weather, right? And so if you have hot or cold environments, that is brought indoors, and it needs to be brought up to a temperature and humidity that's acceptable for the plants. So that modification of the weather outside requires a lot of energy, and that's really where that heat transfer stuff came in. And then I clicked go and ran that model around the U.S. based on different weather and different grid emissions. And the output is some of the maps that you can see online now.
Yeah, I think it's crazy because it really, from what I saw, it really looked like it took like a net effect of total, emissions. Because we've always known that there's been a massive environmental footprint from cultivation, just looking at utility bills. But you guys really took, I guess, a full spectrum approach to greenhouse gas emissions. And when you look at, energy usage and, inputs and stuff, the effect is profound. So, in terms of indoor cannabis cultivation, what are some of the major factors that influence these greenhouse gas emissions?
Yeah, so we categorized the emissions across the U.S. to understand what the largest contributions were. And so we figured out that it doesn't really matter where this indoor facility is located, but the HVAC requirements, your heating, ventilation, air conditioning, the energy to keep that system running and keep your plants at a comfortable environment was really the primary source of energy, and then therefore the primary source of greenhouse gas emissions. The second was lighting, which was pretty interesting for us because I think previous speculation was maybe that lights were a bigger factor. And then from there, it was the carbon dioxide. So the actual bottled CO2 that's used for, increased plant growth, that depending on your ventilation rates can be a significant contribution.
Oh, really? So when I was reading your paper, I maybe I misinterpreted that. I thought that it was like, because it was coming off of a product that was already producing CO2, I thought that was like not included in the calculation.
Yeah, so not the ventilation rates affecting, how much is being emitted. Just like you said, we didn't actually account for any CO2 that's leaving that facility isn't burdened to the cannabis growth. Okay. But if you're consuming more, then you're consuming more bottles, right? And you're consuming more energy upstream to compress that CO2. And that's really what I'm talking about when I talk about the burden. Yeah, so it's a little bit unique with some carbon accounting technicalities here. Like you can have the real world, which probably in the real world we might contribute that carbon, burden it or assign it to the cannabis operation. But with our life cycle sort of standard method, we just assumed, we're going to go conservative here, and we're going to say that was really handled upstream, and that we're only going to penalize the grow facility for the amount they're using, and then that energy to produce it upstream, if that makes sense.
Gotcha. Now, in terms of lighting, were you guys able to kind of determine, the type of lighting used? Like obviously like HPS or ceramic metal halides, are much hotter and therefore use more energy compared to LEDs. How did you guys, address that problem?
Yep. So we, I think I did a standard HPS setup, and I did, basically what I did was I calculated the heat that would come off of those lights. And then that goes into your heat transfer problem, right? Because that's going to contribute to the inside temperature. And depending on your ventilation rates and the temperatures outside, that's just a really complex set of equations to analyze the energy that's needed. You might need cooling, or you might need heating, just depending on what you're bringing in outside and how hot your lights are running at that given moment.
Gotcha.
So the paper also talks about different geographical features that would affect this, which I interpret it as like outside of the actual grow itself, like the
climate.
The climate, yeah. I was wondering if you could elucidate a little bit what role that plays and like how big of an effect it has.
Yeah. So, geography has two primary considerations. Weather, like you mentioned, is a big one, and then your grid mix, right? So, although all of your HVAC isn't handled by electricity, a lot of the components of HVAC are electric, and your lights are electric. So, the grid mix plays a role, whether you have a cleaner grid like California, or for us in Colorado, we have a lot of coal and natural gas still. So that plays a pretty big role. But then also, if we're talking about the weather, as I mentioned, HVAC was the largest contribution regardless of where you're growing. And that's because you're just constantly having to alter outside conditions. We did find that locations that are located in the coasts are generally, more typical or representative of what you would need to grow indoors. So you're not modifying those conditions as much. So that's why those locations were lower in the greenhouse gas emissions, because they just need less HVAC energy all around. but then, as you move inland towards like Colorado or the Midwest, where it's constantly these really harsh, cold environments, pretty much almost every week of the year, you need to modify that outdoor air to keep the plants happy. So that's really what's behind the scenes of the HVAC systems, in my opinion.
If there is so is there an optimal region in the U.S. where it's, really ideal for growing indoor? With like what state or what region would have, theoretically the least environmental footprint?
Yeah, so a lot of locations in California are great. Obviously, mostly that's climate, and their grid is pretty clean. We also found that, if I'm remembering my visual map correctly, I think it was New York that was actually honestly pretty good, mostly because the grid is pretty clean. The climate's not, the best year-round, but there are times when it's pretty decent. And then my understanding is the grid's pretty clean. So, and there's also some, southern, southeast coasts that were good as well. Like Florida was generally not terrible. With Florida, the humidity is really high, right? And you already have evapotranspiration from the plants that you need to consider in your HVAC systems. So bringing in, hot, humid air from the outside is also not great on your HVAC load. So, I think there's just general trends that the coasts tend to be a little bit better from a temperature and humidity perspective. And then inland, it's just a little bit more cold, to be honest. I mean, that's really the driving factor of why Colorado ended up being one of the most greenhouse gas intensive locations, is because, we have the Rockies up to 10,000 feet. And so it's just constantly a really cold, harsh environment. So I think those are the general trends that we saw. Oh, and then Alaska and Hawaii, of course, were not the greatest, but you could, speculate Alaska wouldn't be that great. And then Hawaii was, it's just a little too hot and humid. So, and then they don't have the cleanest grid. So.
And what exactly does it mean to have a clean grid?
Yeah, it's just your breakdown of where you're sourcing, how you're generating electricity. So when I talk about clean or dirty grids, really it's just how many renewables they have online.
Gotcha.
So if you're generating by solar, wind, hydro, those are going to be sort of your clean systems. And then you have
gas.
Traditional petroleum-based like natural gas and coal.
Gotcha. Cool. Thanks for clarifying.
Mm-hmm. So if we were to try and combat these, like, because we're coming across legalization, right? And so in the midst of legalization, we have the ability to set forth rules that are going to potentially mitigate these things, right? Because essentially we don't want these greenhouse gases. I don't know if we've made that clear. But,
it's a pretty clear PSA.
But so like if you were to suggest maybe some policies or like some implementations that could be put in order to improve these, what do you think would be a good route? Like we know like California now is forcing everybody to switch over to LEDs. Do you think that would be, could you put a quantification on what you think that reduction would be? Like, could it be as much as half going from HPS to LED, or obviously not, because HVAC was the biggest component, but
yeah, I guess like
that's a good.
What like policy implementations would you recommend to a state like New York that is about to legalize that might help us mitigate some of these issues?
Yeah, so I mean, just to touch on the California LED program, it can't hurt, right? Like obviously that's a good one, especially because with recreational legalization, at least in Colorado, being around for 9 years, there are startups and companies that have developed great energy efficient lights that I understand can be replaced pretty easily. So I think that obviously that's a good one, but it'll have more impact in locations that have dirtier grids. Because, in California, if you already have a clean grid, even though you're using less electricity, you're already ahead of the curve because your electricity is so clean. So I actually think that places that have more coal or natural gas in their grid mix could benefit from the LED policies. But that's a nuance, right? Like I still think everybody should look towards policies like that mandate LEDs. On a similar subject, there's a policy in Illinois, right, that talks about doing maximum allowable watts per square meter. So looking at your actual light usage and density of where you place your lights. So that's a really good one. But if we think even bigger picture, right, like lights we found were the second largest contributor. The first was HVAC. So if we're looking at, policies, I think that understanding what HVAC systems are out there for adoption, like I said, there's a lot of companies that have energy efficient lights, but there's also companies that have really energy efficient climate control equipment. So understanding what's available and understanding what's applicable in your region, I think, is a really good first step. And then we can also look at other things like waste, right? So like in Colorado, for example, we have the 50-50 mixing rule where, the plant waste has to be diluted 50% before it goes to municipality landfill, right? And so I think that that's something that we could look at, that instead of, allow on-site composting or allow on-site anaerobic digestion that can then, then you can capture your biogas and then use it for combined heat and power. So I think that there's some other policies that, or concepts that we should be focused on beyond lights. I think lights is probably the lowest hanging fruit that we could look at right now. If I'm thinking about New York specifically, I'd have to go back and look at the breakdown there, but I think that HVAC is really going to be a critical one. And I can't really speak to what, a policy around adopting clean HVAC technology looks like, but I think that's the direction that we should be focused instead of lights, because I said if the grid is relatively clean there, lights won't have as big of an impact as something like clean equipment.
One thought on that. With LEDs, they're finding that they can typically run their rooms at higher temperatures and higher humidities. And so therefore, in my head, that causes less need for air conditioning or a dehumidifier, which are pretty significant as far as energy costs, if I'm not mistaken.
Yeah,
so
I hadn't thought about that just off the top of my head. Like, that's a great point. Like, LEDs aren't going to put off as much heat. And so, yeah, that's a really good one. So maybe it's a win-win.
The one thing that I worry, and that I've talked to some friends who are out on the West Coast who are in cultivation, is that, imagine if you have a 50,000 or 100,000 square foot grow with HPS, like the transition to LEDs is going to cost a substantial buck. So if there was, I think there's a reality that, like, if forced to do that, there's going to be businesses that can't afford that, so maybe offering some sort of tax incentive or
subsidy or something.
I'm not a huge, I'm not a big fan of tax, but I am kind of a fan of a carbon tax to be able to, people, it offers an easy way to,
incentivize somebody to do the right thing.
Exactly. So I don't exactly know what that looks like, but the good news is that it's not all bad news, and there are ways to mitigate these things, both from a policy perspective and a practical standpoint. So do you have any, from a practical standpoint, do you have any other ways that, we could look to addressing this big greenhouse gas problem?
One thing you just talked about with the subsidies was really interesting. Because I think with the recent stimulus package, I know that was more of like there's the personal side and then there's the commercial side, but I was reading about the incentives for the rebates on solar right now, right? So if you could do on-site solar, and yeah, I acknowledge if you have a 50,000 or 100,000 square foot building, solar is going to be a pretty penny, right? But if you can get it now while there's a potential higher rebate, that's, something to investigate. So there's some other practical things we can look at. I think that there are best management practice guides out there that business operators can get a hold of and just generally start to read through, adopt, and orient themselves more towards clean practice. There's also a couple certification programs. So there's the Clean Green certification out of California. They've been around since 2004. It's kind of like an organic equivalent, if you will. And I know that there's a one operation in Denver, legal, that has been certified since 2016. And so that's a really low hanging fruit. I don't know what it costs, but I think that the idea is that then you get basically like a stamp, a label that's like, hey, we have a green product, and you can distribute that down to the consumer. So you can make noise about this, as a business operator, brag about the steps you've taken, and just because I think we're in this space that typically the consumers in this industry are green oriented folks, right? I mean, That's a speculation, but like, I think that we're all not trying to do the wrong thing here. And so the more you can be vocal about the initiatives you've taken, just be proud of it. There's another grow operation here in Colorado called Pot Zero that has I think they're zero. I think the idea is they're Pot Zero, so it's zero carbon footprint.
Wow.
And just looking at your some of these other businesses that have these the business plans that have led to being so green. I mean, I think that being vocal about it, communicating, and seeking others that are leading this initiative, just do the best you can do, right? I mean, I think that there are some pretty easy operations that business owners can take. So it's not just a political landscape. I think it's there's three pillars, right? We have consumers can create a buzz and create a demand for green products. We've got business owners and operators that can make a difference in their own facility. And then you've got the policy side. And I think everybody needs to be working together here. It's not anyone's problem. But I think we just need to be experimenting and getting ahead of it before the industry becomes, ideally federally legal, right? And some of these practices are ingrained as a standard.
Yeah, I don't know the exact statistic, but I had heard that, and maybe able to clarify that, like as of right now, like around 1% or a little north than 1% of the U.S.'s energy grid or electrical grid goes to indoor cannabis cultivation. And I had heard as high in Colorado, anywhere between 8 and 13% of electricity. And, let's remember that not even half of the states have really legalized recreational yet. And a lot of those states that have not legalized yet are the Midwestern states that are going to be really the most carbon taxing, states and from a cultivation perspective. So if we don't start addressing the problem now, and the good news is, folks like you are really addressing the problem now, because, as much as we all love the industry and can see what it can do for agriculture and jobs and communities and medicine, etc., if we're destroying our planet in the meantime, then what the hell are we doing?
Well, that's where federal legalization gets to actually come into play and help its policies work better, right? Because if it's federally legal, we don't have to worry about crossing state lines. And then cannabis can become, obviously you're going to have cannabis can become like everything else, right? Where it's going to be grown in its most desirable location. It's going to be in these areas where it's cheap to produce it. And people are just going to flock there because it doesn't matter what state you live in, right? And then, obviously you're still always going to have people in these other states that are going to be doing their own thing. But like, if you could get the bulk of it to move to the coast and we can reduce, I don't know, that seems like the way to go for me.
Yeah, that's actually really interesting you bring that up. That's where we're headed next with some of the next steps of research. We've got a couple different proposals in the works to try and, first and foremost, we need to understand greenhouse gas emissions from greenhouse growth and then outdoor growth, right? Because right now we're speculating that those might be lower greenhouse gas emissions, but because we haven't quantified it, we really just want to understand some numerical differences there. So that's our next step. But then we're also going to look at changes in policy. So if you federally legalize, could you have this central distribution center that, is a huge grow hub, whether that's in California or spread across the coast? What could a really optimal system look like? Obviously I think that might be a financial nightmare because I don't know how you would deal with all the taxes and whatnot. And But from a greenhouse gas perspective or an energy reduction perspective, can a system like that be better than having every state on their own?
Yeah, I know. I do worry about their, federal legalization and having, one central distribution center. I do think that the craft industry is where the industry will prevail, especially on a small scale. It's really these massive cultivation facilities that are, I think primarily responsible for a lot of these greenhouse gas emissions. But, let's not forget, places like the Finger Lakes in New York, one of the best, most rich agricultural regions in the world, right? We have one of the best wine industries in the whole world. Why couldn't that, be for cannabis? Remember, we can also grow this plant outdoors, and now with this big regenerative movement, not even carbon zero, but carbon negative, we did it at our hemp farm last year. We were using all, organic inputs. We were using compost or vermicompost extracts which is literally food waste from the community turned into extract that we use in our plants. And, not to mention, obviously, hemp is a big bioaccumulator. So I think from an outdoor perspective, we could combat to the point where it's actually negative, not even zero. But, there goes that whole argument is indoor as good as outdoor, but we need to weigh in the fact that it's like, as good as indoor cannabis can be, like what's the net effect in the environment? So the good news is I do think we're heading in the right direction. And there's some really great companies out there that are already looking at this very seriously. A company that's very near and dear to me that's kind of in their startup phase is Stem Cultivation. I don't know if you've ever heard of them, but they have essentially what's called the Echo Grow Room, and it's this full, it almost looks like a shipping container that, they've optimized for space, they've optimized for yield. It's, 1/3 of the carbon, 1/3 of the electrical footprint, a fraction of the water input. So I think there's a lot, everyone's kind of focused on like legalization and kind of the more superficial, like, can we grow the plant, blah, blah, blah. But there's a lot of these technologies that are emerging that I think are going to be really, barn busters when it comes to actually project, bringing the industry to, kind of that second phase of growth, kind of coming out of, prohibition, becoming legitimized, and now becoming, a multifaceted, very robust, sustainable and environmentally focused industry. So I think we're a couple of years off, and we'll see what happens in New York in a couple of weeks. But I know that from an advocacy perspective, the environmental impact was something that we, talked a lot about with legislators and stuff like that. So you had we were talking about a question about geothermal.
Yeah.
Earth.
I was wondering if you thought that, like, because I don't know all of these parameters, right, that will go into calculating these greenhouse gas emissions from the grow. But so if you had since we're looking at indoor cultivations, if you were to bury that and like do an underground cultivation indoor style, do you think that could reduce emissions due to like the insulation factor and lack of CO2 loss through the roof, or like will other factors maybe compound that?
It's a really cool, interesting perspective, and like I really like where your head's at. That's really cool. I think that, like, just if I had to guess offhand, it would have an impact. Probably, especially for the cold climates, probably in the positive direction, meaning reducing greenhouse gas emissions because you have less heat transfer through, to the outside, to the cold climate. But when I'm thinking about some of these ventilation rates, so like, you're still having to change over the air really frequently. And that's really where the high energy demand comes from, is like pre-treating that air that you're bringing in. And you're going to do that regardless if you're underground or above ground. And so if I had to speculate, I think the majority of heat transfer is done, or heat or energy into modifying the indoor climate is done through that fresh air supply, and not necessarily through the walls. Like, I don't think it could hurt in cold climates, but I don't know how much it would save, if that makes sense.
Plus, then you also have to take into consideration the tractors and bulldozers and stuff that it would take to dig that hole out and then pour the concrete or whatever you're doing. But
yeah,
right.
That's exactly the life cycle thinking that we do, right? Like, we think, from its infancy to the time this facility dies, like, what are we looking at emissions wise? So concrete is a huge emitter. So if we have to build stuff from the ground up, that's one thing I should say we did not account for was like building a new facility. Our big assumption was saying that you're just going to retrofit an existing facility. So we didn't account for any of the embodied emissions that come from, the concrete in the walls, for example, or like the tractors to bulldoze and level the land or build a foundation. None of that was accounted for. We tried to take a conservative approach on the model and some of the assumptions. So I'm glad we just mentioned that, because I kind of forgot that was a primary assumption, that we didn't include for any construction emissions.
Yeah, I feel like there's just endless variables that you could account for. It's
you gotta draw the line somewhere.
Yeah.
Yeah.
So kind of similar note. We did. I had somebody who found out that we were doing this interview, and they really wanted to get a question answered. And so they were wondering, obviously because your article is blown up across social media. I actually saw on Instagram, it was like the cannabis industry is hotboxing the world or something. It was hilarious.
Yeah, some of the punny headlines are just like out of control. I love it. It's like great humor, but some of them I'm like, that might not be super accurate. Like,
yeah.
Yeah. Well, in any event, she was curious if these studies have been done in other crops, or like if you, after doing it, maybe compared your study to other people's studies of other crops or something of that nature.
Yeah,
like
so I haven't...
tomatoes, for example.
So exactly, yeah, exactly. So I haven't compared on... well, I guess I have, but I don't remember the numbers off the top of my head. But I did look at... So Canada has a lot of data on indoor farming, mostly because, if they're going to be local... Their climate generally in a lot of regions is cold, and so they lean towards indoor farming or greenhouse farming. And so I did a study a few years back looking at the cost and the emissions of growing greenhouse produce. And I think that the challenge when you look at different products is, how do you compare them? And so what I mean there is, if I look at the emissions per kilogram of cannabis, which our study did, and obviously I fully acknowledge that a kilogram of cannabis is insane, but I'm an engineer and I needed a mass to pick, so I chose a metric unit. But then if you're going to compare that to a kilogram of tomatoes, like what's a kilogram of cannabis versus a kilogram of tomatoes, right? So when you start comparing these things, it gets a little bit messy. And there's some guidelines within the life cycle assessment that talk about comparing that denominator, or that we call it a functional unit. And I think that's where we're headed next, in that next phase of research. When I was talking about, we're going to be doing the greenhouse and the outdoor growth environments, some of the policy level. We also want to get a second paper out soon that talks about the actual magnitude, relating these results to something that's more tangible, something that consumers can relate to, or even business operators. Like, there's some jargon and it's still really technical. It's published in Nature, which is a pretty high caliber journal. And although they encourage general science communication, it's still pretty jargony. And so we're trying to come up with, in our next phase of research, how can we relate this to really resonate with just general public, and really get them to wrap their heads around the magnitude and the scale of the problem, right? So that if they can go to a dispensary or a liquor store or a grocery store, they can understand the carbon footprint of their own consumables. I think that's where we're really headed next. It hasn't been done yet. I mean, if I just said right now, like, emissions per kilogram weed or emissions per kilogram tomatoes, it's by far cannabis. But like I said, that's an unfair comparison. Yeah. It's just not.
Tomatoes so much heavier.
It doesn't. Doesn't quite make sense.
So you kind of touched on a little bit now, and I don't know if it's too premature considering this study is still fresh, and it's probably occupying most of your life in a lot of the media space. Like, what's next for you? What are you looking to uncover next?
I think, if I'm staying in this space, well, I'm going to graduate soon. So that's hurdle number one, is like, get this dissertation in defense done. And from there, for a couple of years, right now, I plan to stay in research and academic-based research, to just see where I can go with this. So just because I see there's a need, and I hope that, the information we're finding is valuable to folks. The last thing we want to do is really point fingers at the industry. I'm just trying to help. I'm just trying to, quantify best I can and help inform so that we can collectively as a society just make the industry the best it can be. So I talked about, the greenhouse, the outdoor environments. I think those are our next immediate steps. Policy. From there, just like the listener question about vertical farming, like I personally am really interested in vertical farming, trying to understand the impact that industry could potentially have if we switch to a model like that. And it's a really easy progression from the model that I built because it's just the same principles, right? Like you have a warehouse, there's some lights, some basic inputs as far as nutrients for the plants to grow, and then you have climate control. So I would like to use the foundation that I've built to study as many relevant industries as possible. So I think that's really, as long as I can get, I'm in a soft funding world. So like, as long as I can get an influx of money to sort of keep going and keep doing this research, that's where I would like to go next.
Awesome. Right on. Well, so kind of last to wrap up, if people have questions, which I'm sure they will, what's the best way for them to contact you?
So I think technically my advisor, Jason Quinn, is the corresponding author, but I'm happy to give my email out. It's just my first last name at colostate.edu. Cool. So I'm happy to give that to you guys.
Yeah, and we'll put that in the show notes and share that, and I'm sure people are going to have a lot of questions. So
sorry in advance.
Yeah, sorry in advance. Well, this has been incredibly informative, and I'd
really love to have you come back on the show after you get those greenhouse and outdoor studies done, if possible. Totally. I'm super interested to hear about those.
Yeah, I think in the short term, I think in the short term it's just, there's a lot of factors going on with me trying to finish up. But I think in the short term, our plan, and if I was thinking about the order in which we're doing things, it would be comparison to consumables. So, take what we just found and make that more relatable to the public, immediate. And then from there, a year, maybe 2 years down, we'll have the greenhouse, the outdoor, and then some policy work too. So I would love to come back. And if I have more results and it's informative and helpful in any way, I'd love to come back.
You can come back anytime. Thank you so much for coming on the show. I feel very lucky to have you on here, especially with this, just being released last week. Thank you so much. Congrats on all the awesome work. And I think I speak for both of us, then we're very excited to watch your continued success.
Absolutely.
Yeah, thanks, guys. Thanks so much for having me. Really appreciate it.
Thanks so much, Hailey. Have a wonderful night.
All right, everybody, that's another episode of Cannabis Cum Laude. You had heard it here first. That was Hailey Summers from Colorado State University. We'll see you next week.
Thanks to our friends here at Rockbox Recording and Production in Rochester, New York. They are a full professional podcast and video studio designed by a radio guy for podcasters. Audio, video, voiceovers, editing, whatever. Mouth off at Rockbox at rockbox.com.
You can follow Cannabis Cum Laude on LinkedIn, Facebook, Instagram, Twitter, and Cannabuzz. Type Cannabis Cum Laude into your search bar and you should be able to find us, but the links will also be posted in the episode notes as well. If you want to help support the show, head on over to Patreon, and that will ensure that we're able to keep the best quality sound and video coming to you on a regular basis. And if you liked what you heard today, please don't forget to rate and review the show.